So it was very self-directed. Although like I reached out to the mentors, I got advice and like along the way, but it was purely self-motivated, self-directed.
That's cool. That's cool. I find that most projects where you get to be in the driver's seat, you get the most out of. Of course, you can get guidance when you need it, but if you have that interest in it, then and you want to see what the results are, then you really want it's like your baby. So you have it's like a passion project that you finally have at the end of the day,
Yeah,
right?
definitely, definitely. Like I'm glad I went this route because I was debating about whether going with one of the projects they suggested versus what I'm really interested in. So I had a
Mm-hmm.
few conversations and ultimately decided to go with my interest. And that like it was I was struggling at times. So if it wasn't for that, I don't know how I'd complete it.
Oh yeah.
What was your capstone in?
So it was the lending club. I don't know if you saw the project outline for that. And so I like the fact that for the capstones, there are several ways to get ideas. You have
Mm,
the company pitched ideas. You also have the instructor frameworks. They also have proposals for you to take different pathways. So those provide a bit more guidance. And so you basically are provided a framework or skeleton to work from, which you can then take in a further direction, or they can be self-directed. And there was a lending club one that I think had been around for a while, but with many different variations on it. And that looked interesting to me. Um, so and I think having somebody else who was more versed in development, web development, as far as DevOps and all of that, it really helped because for me it was more substantive coding that I was more familiar with because that's what was taught, and he was good at both.
mm,
So I leaned on him quite a bit, and I found it a really good experience because it was something that was not taught as much until towards the end of the program. Time
yeah,
series, it was in the advanced topics portion. So
yeah.
it really was interesting because it was more implementation of something I was familiar with, but that I didn't really know how to carry out. And it was less high level math. Like it with deep learning and all of that, the math can get pretty advanced and hairy. Time series, it's more knowing how to deal with some of the it approaches data cleaning in a sort of different way. So it was interesting to see how you did that with blocks of time compared to compared to so there's longitudinal and then there's when you didn't have to deal with different blocks of time. So
I didn't. I'm unfamiliar with time series. I didn't dive deep into it at all, but it sounds interesting.
I think Martina's waiting.
Oh, sorry.
Are you waiting? No, I think
No, no,
I
no.
kept on
It's really
talking.
interesting. Like the
Yeah.
topic you're talking about is really interesting. But feel free to start anytime.
Ah,
But
great. Okay. Okay. Hi, everybody. Thank you so much for joining us today. My name is Sophia, and I'm an admissions officer here at NYCDSA. And today, Tyrone Wilkinson, who is an alumni of the school, is going to present on attention detection with images, videos, and live feeds. He did this as part of his capstone, and he has stayed in touch with the Academy. So our school is known for its engagement with students both during the boot camp and afterwards. So Tyrone here, he's a very good resource for not just capstone inspiration, but also him and other alumni for you to reach out to for their personal experiences and their thoughts on the boot camp. Let me share my screen here. I'm here on behalf of the admissions team to greet both old visitors in addition to newcomers. So because of the diversity of the audience, I'm going to keep this presentation as high level and as comprehensive as possible. If you have additional questions, feel free to drop it into the chat box or to email the admissions team or me personally. I'll leave both emails at the end of my part in the webinar. A little bit about the school. NYCDSA is a data science.
I'm sorry, I don't think you're sharing your screen.
I'm not sharing my screen.
I don't think so.
Oh, I pressed present on PowerPoint, but I did not share my screen.
Oh,
That additional functionality failed
now
us.
it works.
Okay, now it works. All right. Okay. All right, so a little bit about our school. NYCDSA is a data science academy. We offer boot camps, course bundles, and individual courses in order to tailor your education both to your needs and your time flexibility. We offer two types of boot camps: the flagship data science with machine learning bootcamp and our data analytics bootcamp, which stops short of data science and machine learning. And you can consider it a mini bootcamp for those who want to dip their toes into data science. And if your interest is piqued during your stay in data analytics, you can then transfer into data science. Both the data science and the data analytics bootcamps are offered in on-site live streams and online pre-recorded versions, again, to personalize your experience. For those who prefer to pick and choose their courses a la carte, we offer professional development courses, which often qualify for early bird discounts. And we also have bundles, which is a series of 3 courses, which also qualify for bundle discounts. We are the only bootcamp that teaches both Python and R. In recent years, Python has dominated the landscape for data science, but R is also very powerful and is commonly used, especially in research and the life sciences. And NYCDSA want our graduates to be well-rounded and competitive. So knowing both will make you that much more adaptable in your job search. You will work on 4 industry projects during your stay at the bootcamp. Our school takes a project-oriented approach for you to demonstrate comprehension of what you've learned during the bootcamp, and this will also give you an opportunity to collaborate with your classmates. You have the opportunity for your capstone to work on an industry-pitched project from one of our industry partners. So that is a very valuable opportunity for you to get your foot in the door, to show that you can handle the rigor of an industry project, and to make yourself more visible to the data science community. We have very robust job placement support, and this is done in a multi-pronged manner. What distinguishes our bootcamp from others is that you get unlimited one-on-one mentoring support. And the mentoring extends to job support as well. It's not just homework and projects where you can get guidance on. These are private sessions that you choose from a list of mentors whose bios interest you. They might work at a particular company that you like or a sector you're interested in applying to after graduation. You reach out to them, schedule these sessions, and you can then meet with them as frequently as you need. We offer unlimited mentoring. Secondly, career services support. You will participate in mock interviews, in resume reviews. You will be added to a job portal, which the recruiters are from our industry partners, and they have specifically indicated that the only applicants they are interested in are bootcamp graduates, to show that you can handle the type of rigor that they're looking for in potential applicants. So you have lifetime access to this. If you find a job through this portal, you would work for them. And if you, after a few years, you're interested in other opportunities, it's still available to you. You come back, you tweak some settings, turn your visibility back on, and through that, you indicate to the recruiters that you're interested in opportunities. After you graduate the bootcamp, your relationship with us does not end there. You will be enrolled in a post-bootcamp study plan where you will regularly meet with your peers to do mock interviews, to work on elevator pitches, to then meet with a faculty advisor regularly to track your progress. You will be given sets of technical coding questions to expose you to the different types of questions that are commonly encountered during tech interviews and to make you comfortable in that scenario. In addition to that, we also have mentors who do live coding sessions with you. So this simulates the actual technical interview. We want to make you as prepared as possible. We have over 2,000 alumni working across the globe, and our diversity is reflected in both our student body and our faculty. We have been consistently rated as the best data science bootcamp and the best online data science bootcamp by switchup.org. These are the upcoming bootcamps in addition to their start dates. So we have the on-site live streaming in-person bootcamp where you have the morning session and the afternoon session, and these are offered in real time. The next session begins September 27th, and the subsequent one is offered January 3rd of next year. There is also the full-time and the part-time pre-recorded bootcamp where lectures are pre-recorded. And aside from the pre-recorded lectures, the interactivity with both peers, faculty, and mentors is identical to the in-person bootcamp through Slack forums, through live learning sessions, through live office hours, and even through happy hours. We want to make sure that because you will be collaborating with your peers on projects, that you have the opportunity to get to know them. So these are not self-directed in that you enroll and then you're left to figure things out on your own. There is plenty of support and engagement along the way. And then the data analytics bootcamp, offered both remote live and in person and online, starts September 27th. If you're interested in applying, the application process is straightforward. You submit your application, after which you schedule an interview in a few days. Either Noah Escobar or myself will interview you. If all goes well, you will be sent a tech assessment, which you'll complete within 48 hours. You return it to us. We forward it to our data science instructors, and they will grade it and provide feedback, which you will receive within a week. And you will get your decision by then. If you have any additional questions, please email the admissions team at this email address here. And thank you so much for your time. I'll hand the mic over to Tyrone now.
Thank you, Sophia. I'll start presenting. All right, so this was this was my capstone project, which I expanded a little bit, which you see at the end, but it's based on attention monitoring. My name is Tyrone Wilkinson. So my inspiration is autonomous vehicles, specifically self-driving cars. I just think they're extremely cool. Personally, I'm the type of driver who's in the right lane on cruise control 90% of the time and going the speed limit. So I look forward to the day where I can just lay back and relax and let my car drive me anywhere. But less selfish reasons, it'll save tons of deaths worldwide. And I don't think many people understand how generalizable the solution to self-driving cars will be. I think it's going to be applicable to many industries. And the biggest thing which underpins my whole data science career, so to speak, is AGI. Like I think I see solving self-driving cars as a step towards AGI. And I hope in my career, I'm able to contribute to it in some way. So the two companies I think are leading the self-driving space is Tesla. Elon Musk has Tesla. Andre Kapathi leads the autopilot team at Tesla, and George Hotz, who's the president of Comma AI. And if you look in the space, there are different types of software and hardware approaches. So it's going to be interesting who wins. Yesterday, coincidentally, was Tesla's AI day. I didn't get a chance to see it, but hopefully tomorrow or no, hopefully sometime next week, once I have some time, I'll be able to catch up. So driver monitoring is just one aspect of self-driving. I remember in one of George Hodge's interviews with Lex Friedman, he was convinced that Elon Musk would have to add driver monitoring cameras because at that time they weren't monitoring the drivers, and he was ultimately right. Like I'm sure many of you, if not all of you, have heard or seen people reading or sleeping behind a wheel or people in the back seat while the car is driving. But so all that press and the reality that you can't really trust drivers force their hand, and also Volvo's hand as well. So the implementation is to bring attention monitoring into the home. So basically, driver monitoring software is just a camera and a neural network, which seems pretty straightforward and scalable. So you swap a camera mounted on the rear view for a laptop camera, you essentially have my project. There are many applications to this. So because many newer models will have attention monitoring and driver monitoring software built in, I think it's possible to incorporate the software into aftermarket dash cams, which will give drivers with older vehicles the option to implement it or use it in their cars. Employers could use attention monitoring software to increase workplace productivity. I know that'll be very controversial, but it is an option. Students could use it to increase their focus. I see that Zoom added productivity tools called Zoom apps. So video chat platforms could also implement it either for the moderator to make sure everyone's listening is actually paying attention, or the participants. There are many possibilities, which I'll get back to later. So this is essentially how I proceeded. I had to understand neural networks. Like it was completely foreign concept, understand what they are, what they do, how to build them, etc. I had to develop a mostly realistic outline of my project, collect and prepare the data, build, test, iterate, evaluate, revise, repeat, and then stop at some point. And I'll go deeper into each step. So I'll include some of the resources I utilized at the end, but basically I had to understand how everything worked. I chose CNNs, convolutional neural networks, because they're commonly used in image classification. They're preferred over traditional neural networks for a few reasons. One, they have much less input nodes. They tolerate pixel shifts in the image, and they take advantage of the phenomena that similarly colored pixels in images tend to be close together. I used transfer learning, which basically using a pre-trained CNN would yield much better results than training one from scratch, given my limited data set. Like I had about, I think roughly 10,000 images. And if you really want to have a solid data set, you need to have at least in the millions. So I ended up using a model trained on a subset of the ImageNet data set consisting of 1.2 million images with 1,000 categories. I used ResNet 152. It was chosen due to its better performance, proven performance compared to other pre-trained architectures offered by the Keras module and TensorFlow. Different deep learning frameworks like PyTorch have different models. But so since I was using Keras, I chose ResNet 152. Its depth is a big contributor to its effectiveness. And you'll see, well, I've noticed in deep learning in general that if you just increase the depth and the breadth, that increases the accuracy. And I'm pretty sure, I'm not sure how far you could take it, but I don't think we're nearly close to the end of that yet. Bigger is better. Just look at the language model GPT-3 if you haven't heard about that. So 152 stands for 152 layers. I believe there are 150 convolutional layers, one max pool and one average pool layer. And so these are various frameworks. Being a high level API, Keras was definitely the easiest to work with. And like I've read that in combination with TensorFlow is actually a great tool to use. After the project, while I was expanding it, I experimented with MXNet and PyTorch. I hear PyTorch is better since it offers more granular control like TensorFlow with a much cleaner syntax, but each has its strengths and weaknesses. Other frameworks I didn't include are CNTK, Microsoft Cognitive Toolkit, and Deep Learning 4J, DL4J. So this is my outline. Training a pre-trained CNN to classify images, using that CNN to classify video clips, and then using it to classify live video. Initially, I got through A, B, and C, and I was able to. Right now, I'm working through D and E. Oh, D. Right now, I'm working through D. I was able to complete E. So this was the longest and most tedious portion of my project. You'll see that working with the data is usually always the longest. I was unable to find a single data set that met my requirements in regard to the subject's body position, since it had to be someone like I am sitting at my desk looking at my laptop camera. So this body position and diversity, so like a mix of races or skin tones, and the accessibility of the data. So I didn't want to go through like a month-long process of emailing, trying to get permission to use whatever data was available. So I spent a great deal of time compiling and labeling the data myself. I generated many of the photos on the website Generated Photos to get the greater diversity of skin tones. On that site, you can select the race and gender. Unfortunately, since it's AI generated, some of the models were a bit off. Like they weren't very human-like. But I work with what I had. So some I got rid of, some I didn't, because it was just too many images. And also on this point, there is a problem in the real world where bias is inadvertently trained into classification algorithms. So it is something to keep in mind if you go this route or if you're interested in image classification. But yeah, the data portion was insane. These are a couple of screenshots from the website. Generated photos. It gives you a lot of control. You get more control if you're just generating a single face, but you still have a decent level of control generating multiple faces. So all in all, I ended up with 10,247 photos in total. I divided them manually into a 70-30 train evaluation split, and further divided 30 into a 15-15 validation test split. I had to do it manually since the photos I got the photos from different sources, so I wanted a somewhat even distribution. And looking back, since I barely utilized the training data, I'd probably do like a 70-25-5 split next time around, or if I was to do something like this again, or increase the size of the training set. Here's a finer breakdown of the data. I tried to, like, working with 10,000 plus photos manually, I tried to come up with a somewhat even distribution of skin tones and and so on. So these are examples of the data sets. UCC. I was thinking actually yesterday that it would be interesting if I was able to use the infrared camera that are in Windows Hello compatible devices. So like driver monitoring cameras in cars have the infrared camera, so you could see in the dark. You can see the people's faces in the dark. So I was wondering if I could do something similar for a different use case, but because you wouldn't be very productive working in the dark. But yeah, here are some examples of the data. So the training data was augmented to create a more diverse data set and to make the model more generalizable. And as you can see, these pictures aren't very accurate. The first set of parameters I used did achieve the goal, but resulted in unrealistic training data. So I tweaked the parameters the next time around when I retrained the model. This was more realistic. All right, so initially I trained the ResNet 152 with frozen base layers and unfrozen fully connected layers, the top layers that I constructed. The base layers were frozen to prevent their weights from being updated during training. And you could see the accuracy and loss. And as I mentioned before, I tweaked the augmentation parameter to get more realistic images and unfroze the last convolutional block so that it could be trained alongside the header constructed. I did this in an attempt to make the model a better predictor, and like it was more accurate, right? It did report a better loss and accuracy, but there was also a greater degree of overfitting. So in order to resolve this or to help this issue, I could perhaps tweak the augmentation parameters and use techniques like regularization. I think those could help mitigate the overfitting. So to my surprise, there was no real difference in code between classifying video clips and classifying live video from my laptop's webcam, which was great because I was pretty burnt out by the end. You know, I used the OpenCV, which is the computer vision library in Python. So here are a few things I noticed. My model was better at predicting when I wasn't paying attention versus when I was paying attention, even though the data sets were pretty equal. And the further away I was from the camera, even sitting at normal laptop distance, the less accurate it was at detecting my attentiveness. And I did know why, or I did see why looking at the images. Like if you could see, many of the pictures are pretty, after the resizing the images, many of the faces are like directly in front of the camera. So, and anyway, the third issue was it was better at detecting attentiveness based on head movement and the presence of obstacles versus eye movement. So I mitigated the first two issues by adjusting when the model would classify an image as being attentive and not attentive. So instead of labeling the image as attentive with less than 0.5 prediction and not attentive equal to or greater than 0.5, I labeled images with less than 0.99 prediction as attentive. And here are the results. So just ignore those values. I was at the time I was gonna do something with the numbers, like multiplied it by 100, and I was gonna perhaps change it from anyway, just ignore those values and focus on the pictures. So after the change, here are the results. It became much more accurate. So something tells me that converting all the images to grayscale would lead to better accuracy. I think it'd be a combination of there being less noise, reducing this information, like unnecessary information, and allowing the model to focus on the important attributes. I also noticed that the model performed worse if there was a light source directly behind me versus on the side of me for some reason. Perhaps that could be somewhat alleviated using grayscale. And also what I would do differently is that after the first iteration, I would have learned how to train the model on AWS, since it took, it took like four to 5 days running nonstop in order to train the model. And I went through a few different iterations, so that was a lot of wasted time. So learning how to do an AWS, the training on the cloud would have saved more time, been more efficient. And lastly, I would have labeled the data better, regardless of the architecture you use to train parameters and so on. The results ultimately tied to the data. Because there were so many images, like at some point, I just got tired of going through the pictures and labeling. So perhaps I could get interns or something to do that for me in the future. So I did manage to deploy a web app for the model. I could include a link in the chat. So, and I could do like a quick demo as well. So Streamlit offers both the framework to create data apps in Python and a platform to deploy the apps. It's definitely worth checking out. I think personally it's better integrated and easier to use than RShiny or even anything that Python has to offer. So let me see if I could do a quick demo. I got to change the screen of sharing. All right, so I'm gonna just go through this again. It uploads the video. I enter the frame. I choose clicks. Or you could also play the video. And it outputs a score. So whether you're attentive or not, and your ultimate score at the end. So my final score was 68.182. Yeah, so I noticed that while testing different videos, there were, my model could definitely use some tweaking, but like I spent a lot of time on this project and I'm ready to move on. Another addition was like I mentioned, using AWS. This was the initial outline I came up with just scanning through the documentation. However, after I completed the project, I made a few changes. I think it would make more sense to train the model in AWS, but instead of using PyTorch, use Apache MXNet, since Amazon adopted that framework as their framework of choice a few years ago. And I'd redo my project using PyTorch locally. So that'll get me more exposure to different frameworks, which I wouldn't do on my own. And this is the revised version of the outline and the sneak peek of what to expect in that notebook whenever I upload it to GitHub. I plan to be very specific so other people could follow my steps, because it's a little convoluted initially. And the Amazon's documentation is good. It's just a little unorganized and there are some broken links, but once you find everything, you'll be good if you want to learn how to use AWS. And they also have great code examples. However, some of the code is outdated, but it's not difficult to update on your own. And the third addition I mentioned was redoing my project using PyTorch on my laptop. Here's an example of the image augmentation image augmentation in PyTorch. I actually liked it better since it does offer more features, and it is obviously Keras is much higher level, so PyTorch is noticeably faster. It's just more difficult to get used to the syntax. I think Keras spoiled me a little bit. In any case, this was definitely a fun project. Aside from the data collection and preparation, I don't have the notebooks using AWS and PyTorch in my GitHub yet, or the complete version yet, but I plan to update my blog and my GitHub account when I'm done with those. I mentioned some real world applications earlier, but aside from that variety of implementations, machine learning models like the one I made will increasingly have immense real world impact. I really think this is the age of AI. I think we'll have self-driving cars within the next few years. I believe we'll have digital avatars with human-like personalities, and it'll be, it's really a solver issue in my opinion, but it will be crazy once the hardware catches up with that. We'll have physical assistants in our homes and work, and then somewhere along the line, we'll finally have AGI. And I believe all the underlying algorithms will be neural networks to solve self-driving cars. That's my goal. Thank you for your time. You feel free to ask questions about the project or my time in the data in the boot camp or anything like that.
Wow, it was really interesting. But do you guys have any questions? Feel free to ask Tyrone as he's here. So you spent a month on your project on the campus?
I think like thanks, Joy. I think it was something like that, maybe a month or a month and a half. Like learning, and I included the resources at the end, but took a lot of reading, a lot of videos, and a lot of iterating on my laptop. And because I didn't learn how to use AWS, the training took a long time. But even before the training, going through 10,000 plus pictures one by one, labeling them, that was the worst. And I don't, well, it's a part of data science, but I don't recommend that to anybody.
I noticed that like PyTorch and things, do they cover it in the data science bootcamp?
No, only TensorFlow and Keras.
Yeah. Yeah, you did a lot of self-learning, right?
Yeah. Definitely choose a project that you're interested in. Because I felt like giving up at different points, but this motivated me. Like, even before I joined the bootcamp, I had the goal of working with self-driving cars. So
Yeah.
this bootcamp helped me to get there.
Dwayne asks in the chat, do you have any tips to speed up the training? For example, 3 to 4 days.
Yes, use cloud services. Then you could choose like a powerful GPU and you'll have the training done within days versus using a laptop. Unless you have a laptop with even if you have a laptop with a powerful GPU or personal computer, I think it would still be helpful to learn how to use cloud services.
I think a few months ago, we had an alumnus who came and did an event, like a speech on how to deploy a machine learning model to the cloud or something like that. So if you want it, I can send it to you later or something. Just
Sure.
yeah, it's very useful.
Yeah.
Any other questions for Tyron? But yeah, it was really interesting and a lot of work.
Yeah, definitely. Nah, I've been in IT most of my career, so it was a pivot into data science. Like I always had an interest in AI, so I knew that pivot would occur at some point in my life. I just wasn't sure when, and um, last year was just time to to make it happen.
So before the data science bootcamp, you didn't really know how to code, I don't know, Python or.
I had so my academic history is interesting. It's not normal. I did have a computer science background, so I knew how to code and stuff like that. But leaving college, it was just easier. I was working, like I taught myself everything in IT. Like I got a part-time job in college in IT. It was just easier to get a job in IT after college. And I always knew I was going to get back into computer science, but I wasn't sure how. And the interest in AI, that's where the connection to data science came in, because like my interest being AI and self-driving cars, those are very well, anything like that is very data heavy, and what underpins all of that is a neural networks. So
But it's really good that you have a direction, like you know what you want to do. So you're gonna
yeah.
focus more on that. Jocelyn asks, the final prediction score was 68%. How do we interpret that?
All right. So every frame, basically, um, I classified every frame uh, as attentive or not attentive, and then just divided it by the number of frames. So it was nothing crazy.
Other questions for Tyron? And yeah, she was a great presentation.
Thank you.
Did you use any other algorithms beside neural networks?
No, no. Like there were I created different functions that I use, and I use different various libraries, but the main algorithm I used was convolutional neural networks.
Reinforced learning?
What do you mean?
Um, Hi, Dwayne, could you rephrase it a little bit? Yeah, it's one of the questions in the chat. Reinforced learning, self-learning.
I'm not following you, doing. It could be my lack of knowledge also, but I'm not following what you mean.
I'm gonna allow you to talk, so Dwayne, you can unmute yourself and ask him directly if you want. I'm not sure. Oh, you're okay.
Like I used transfer learning and fine tuning. I um, I guess those are their techniques, but the main algorithm was convolutional neural network.
Is there any measurement how well the prediction score is?
Um, there is a measurement, like the numbers. I I could create a measurement myself. I think that was the direction I was heading in when he saw those numbers on it. Let me bring it back up real quick. Yeah, like initially, like it just tells you. So if the model thinks it'll give you a value. So since I had basically two different categories, the first one was attentiveness, the second one was not attentiveness. It'll give you a value between 0 and 1. Between 0 and 0.5, or less than 0.5 would be attentiveness, and greater than 0.5 would be not attentiveness. The closer it is to 0 would be how much it thinks the image is attentive, and the closer it is to 1 would be how much it thinks the image is not attentive. But I didn't. I should keep. I guess I could add those values back in the app. So I guess to give everyone who uses it a better idea of how well it's predicting.
She said, got it. Thank you. Any other questions or comments? Anything? If not, thank you so much, guys, for joining in and hear Tyrone talking about his capstone project. So this capstone project is one of the 4 projects that bootcamp students have to present and do. And in case you guys are interested in our bootcamp, feel free to check our website, nycdatascience.com. Or just feel free to email our admissions officers at admissions@NYCDSA Academy. Yeah. And
Let's say one quick thing.
yeah.
I think when I was asked how I came up with a prediction score in the app, what I meant to say was I just added up the number of frames that are classified as attentive, and then just divided it by the total number of frames. That's what I should have said.
Okay, we'll keep that in mind.
And I'm also willing to just share the slides with anybody who's interested.
Oh yeah, if you guys are interested, yeah, you can send it to me. I'm gonna share it maybe with people who attended this webinar, and they can also email our academy, I think. Yeah, but yeah, it would be great.
Right.
Like your app is really interesting. I wanna try it myself, like later on.
Yeah, let me know. Let me know your thoughts.
It's gonna be fun. But yeah, questions, comments, anything? But yeah, thank you so much, Tyrone, for taking the time and like putting this up and presenting it. I hope you had fun. And yeah, we're gonna stay in touch anyways. So
Definitely, anytime.
yeah. Okay, so I'm gonna close the room, and whoever participated will receive the slides so they can like try the things themselves, maybe. Yeah.
All right.
Bye guys, have a nice one.